Here's a way you could bench test a relay. This is what I did initially with that system relay, just to see if it was good or bad. Now, what you'll do is you'll take your relay, and you have to know what terminals are what. So let's go ahead and move him out of the way. Now this might be a little bit difficult to see. Okay. We've got two terminals here. These are the relay coil control. Okay. This one is marked 85. This one is 86. This is the switch. Okay. One is 30, one is 87. This one is 30. Sorry, this one here is 87. This one over here is 30. All right, so if we look at the side, just forget about that made in China. One thing that we see, this has a relay suppressor diode built into it. That's what that little triangle shape there is at the bottom. It's shown between 85 and 86. Now, it might be difficult for you to see. 86 has a little plus mark, positive mark over the top of it. It's imperative, if you've got a relay with a spike suppression diode, that you have the polarity correct on terminals 85 and 86. 85 needs to be the ground side. 86 needs to be the positive side. That diode is placed in reverse bias during normal relay operation. If I attempted to put power into 85 and ground on 86, I would forward bias that diode, basically causing a short to occur. And if I've got a computer that's controlling this, there's a good chance that it may damage the driver inside that computer. So we definitely don't want that to happen. So I'm going to go ahead and put a red lead on terminal 86 and a black lead on terminal 85, so hopefully I know what's what. And then we're going to check the resistance across terminals 30 and 87, which are these two. Now, if I check the resistance across these terminals now, I should have OL. It's because I've got an open switch. So now, when I go ahead and make the connection, black is on ground. Relay's turned on. I should go to very low resistance across the terminals, 30 and 87. And there I've got between 0.2 and 0.3. So according to this, the switch is good. You can also measure your resistance across your relay coil. And this is somewhere usually in the neighborhood of 50 to 150 ohms. It's about 125 or so. So if you've got a known good one, okay, then you can compare that. Otherwise, this is at least telling you whether you've got an open in the coil circuit. All right, now, we've got another issue that we need to deal with. One in how to determine whether that diode is okay or not. Now, you can't check the diode in this circuit with a diode checker on a meter. If you attempted to check it in the diode check, that basically it's going to show you it's a shorted diode. You're going to have very little voltage in either direction. So one way of checking, and I don't 100% like this, but one is using a test light. Now let's move him out of the way. Now, as far as using a test light, what I'm going to do, I'm going to put the black lead on a ground. So I'm going to go ahead and move this, and I'm going to put my test light now on the positive terminal of my jumper battery here. So what I'm going to do, I'm going to apply the normal direction of current, positive going into 86, Ground is going to be on 85. And the relay is clicking. And I have no light from my test light. Now again, you've got to be very careful with this. You can actually cause damage to that diode if your test light draws too much current. Now, rule of thumb I like to follow if I use this test, I'm looking to have a test light that's drawn no more than about twice that of the coil current. All right, now, when I put my battery positive through the test light onto terminal 85 now, and the ground at terminal 86, I'm going to forward bias that diode. What should happen then is the diode basically is going to allow current to pass, and you see how the test light comes on, and again, just a tap. Relay does not click. I'm not energizing that coil. All of the current is going through this light bulb. It's going through that diode that is forward biased. So this is one method of checking to see if that diode is functional. When I've got it biased the way it should be, positive into 86, ground at 85, my test light will cause that relay to click, and you can hear it, it's switching it. When I reverse bias it, when I reverse the polarity, forward biasing the diode, my light lights and the relay does not click. Okay, now another method of checking that diode to see if it's functional is using a very fast meter. Now, I've got my ancient old fluke here. It's an 87, not an 87, 235, whatever. It's the old 87, no number or no suffix on it. So what I'm going to do, I need to set this meter so it is able to measure very quickly, and I can put it into a peak min-max mode. So what I'm going to do then is measure the voltage spike that is coming from this relay coil. Now, two ways really of doing this. One is going to be to measure the voltage across the coil, across 85 and 86. The other one is to actually measure the voltage on whichever side is being controlled. Okay, here's a good relay. I've got on pin 86 voltage, so that's going to battery positive, my little jump pack. And on pin 85, that is going to the negative terminal of the battery, or the ground side of the battery. I also have the meter leads clamped onto each side there. So red meter lead is on pin 86, black meter lead is on pin 85. And what I'm going to do, I'm going to go ahead and just tap the negative terminal here, and I'll energize the relay multiple times. Now before I do that, I'm going to make sure that my meter is set for peak min-max. Now as far as the range goes, I need to make sure that I am on my high scale, and it might be a little difficult to see, but there we go. I've got the range up to 4,000 volts, so I'll back up here so we can see a little better. All right, I'm going to go ahead and min-max, and then peak min-max. That'll put this meter at its fastest sample rate. And again, I'm going to just touch the negative terminal of this jump pack. Relay clicks. And I'll do that several times. Okay. Now, we'll go ahead and see what our minimum, what our maximum is. Minimum, minus 12 volts. Positive, 24 volts. So we got about 36 volt spread there, and the diode is doing its job pretty well. Next, I'm going to go ahead and hook up a known bad relay. This is actually a Harley system relay, and the diode in it is open. So I'm going to do the same thing I did with the good relay. Min-max, then peak min-max. All right, now we'll tap the negative terminal here a few times. All right, see what the minimum minus 296 volts. Positive was 100 volts. So I've got somewhere in the neighborhood just under 400 volts out of here. That is definitely enough to hurt a driver of a computer. In this case would be the ECM or PCM driver controlling this system relay. So this is again a good way of testing to see if the diode was bad, other than using a test light. But again, probably one of the better ways of doing it is if you use an oscilloscope. Okay, well, that's all I got. Got to see a good and a bad relay.